Hey, good afternoon, everyone.
Hello. Hey, Joe. How are you? This is Ali.
Hi, how are you, Eddie?
Very good. I hope you're doing well.
I'm fantastic. Thank you.
So, first of all, welcome and thank you for doing this. We truly appreciate it. Let's wait for a couple more minutes. Yes, we can see your page and we can see your camera.
Awesome.
We'll wait a couple more minutes to give a chance for people to join, and we'll start promptly in 2 or 3 minutes.
Sounds good.
All right. Nadine started the meeting. It was recording. Do you want us to record this or?
Yes, the meeting will be recorded. So on, we'll send you guys. I will send you the recorded link so that LebNet can also use it in future reference, and we can also MSFEA.
Sounds good.
Sounds good. Thanks.
Eli, do we have a full hour, hour and a half? I saw that the invite is an hour and a half.
It's up to you, but we prefer to keep it for an hour and leave some time for questions and answers. but if you would like to keep it for an hour and a half, that's also fine.
No, I think I can do it in about 50 minutes.
Perfect. Perfect. Okay, I think I would like to start, and we'll let people join in as they come in. Okay, so good afternoon, everyone. Welcome to this special presentation by Dr. Joe Zoghzoghy. It's our pleasure to host him here at part of the LebNet and Silicon Valley collaboration between MSFEA. I think this is our first seminar this year, so we're very excited about it. Let me introduce Joe for you a little bit. So Joe started his academic track here at AUB, and he got his BE and ME, so he's our alum. And we're very happy that he is now presenting to us through his career, where he's ended up, and we're going to learn from his experience. So after AUB, he went and acquired his master's and PhD in robotics at Southern University. And then his first job, I think, was as a product development manager at MP Flow, where it's a startup, and they developed a multi-phase flow meter for the oil and gas industry. Then he moved to Bastian Solutions, where he started as a mobile robotics manager, and he founded the R&D department business unit there on the development of advanced robotic systems. And then currently he's serving as the CTO at Bastian Solutions, a Toyota advanced logistics company. He's responsible for the development of technologies in the warehouse automation space. And I think he's gonna talk to us about the recent challenges in automation and the automated storage and retrieval systems. So without further ado, I would like to welcome Joe, and Joe, the floor is yours. Please go ahead.
Well, good afternoon, everyone. And I don't know if we've got people dialed in from the US. Good morning. First, let me start by thanking Dr. Shamas for the intro. And I'd also like to thank LebNet and the AUB family for this wonderful opportunity to present to a very special group the work that I've been involved with since I graduated from AUB. Let's see if we can go to the next slide here. All right, so this is my agenda. First, I'll briefly go over the research I did at SMU, and I'll also introduce the company that I work for, Bastian Solutions, and later I'll focus on warehouse automation and what technologies are employed there, as well as what type of new trends are emerging. I'll talk a little more about the challenges in brownfield facilities. These are facilities that already exist and where you try to implement automation. Versus, greenfield facilities are brand new facilities that you integrate equipment in. I was also asked to give a little advice to my fellow UB students so that maybe I can make an impact one way or the other. So I'll try to get there in time. All right, SMU. Went to SMU. I did research. It was in robotics, and the motivation behind that research was to explore robotic locomotors that are not necessarily inspired by nature. This is a family tree of dynamical systems that can represent a general scheme for locomotion. You start with a simple mass, then you add more masses and linkages and revolute joints, and you get different generation of dynamical systems. And it was shown that, each generation inherits the locomotion gates of its previous ancestors and creates its own new ones. Out of these systems, you can identify here, let me put a laser pointer, a bipedal locomotor. This is how humans walk. They get a stable gait, and this is how they do the walking gait. But you also can see worm-like robots and systems. And really, the focus of my work was on investigating creating a system that can regenerate gates for that first generation here, is what I call a baton. So let's talk a little bit about gate. Well, if you get a mass here with a surface, and you throw at a certain velocity and initial condition, it'll bounce and eventually die out. But if you put it on a decline, or if you give it a little more energy at every impact and compensate for the losses there, it will get to a stable gate, and that would be a bouncing gate. So what happens if you take another mass and add a link and create a baton system? This is a baton. That baton will inherit the same bouncing gate of a single mass, but it will also have its own different gates, for example, tapping, galloping, and hopping, and back and forth tapping. So my work was to explore these gates and see how we can replicate them in a actual system. And in order to do that, as I mentioned before, you gotta give energy back one way or the other. And the way I envisioned it is by creating these inertial forces on the masses of the baton. And the way I did that is basically adding pendulums or pendulum-like systems to these masses. In the case here, you can have two masses on each of our original masses here. So two pendulums on each of our masses, M1 and M2. And if you spin these pendulums in opposite directions, they will meet at a rendezvous angle. So if they're spinning constantly at an opposite direction, you get a force, an alternating force, because of the centrifugal forces. And the resultant force is in that direction of the rendezvous angle. And if you control that angle, you can create forces on the baton and hopefully create some sort of a gate that you can capture. So in our case here, see if we can get that video to play. So here you see a tapping gate. We do have numerical modeling of the impact through a spring damper system. So that a dashed line represents where the spring dampener system are engaged on the baton. So you see here in the air, and then you get an impact. And so the force helps it propel forward, backward, or sometimes it can drag. And by changing these parameters and playing around with all the different variables here, you can start looking at different gates, different limit cycles. And there are areas where you can see tapping along with dragging, or if you were actuating on one side of that baton. So not only we did explore the gates with BI numerical simulations, we also built a prototype. And here you see initially it was dragging, and then you give it a different energy, you put it on a different energy level, you see a cycle that's a tapping gate. And here you see masses. The way we did these, I did these masses, you've got to have a balanced system. So with these triangular masses, I was able to put the center of mass in the sagittal plane of the robot and keep it stable. This is an onboard video. This is bringing back a lot of good memories, but these robots are not even close to what we do right now. And I'll show a couple more gates here. This is a galloping gate where you have actuation on both sides of the baton. And you can see here in slow motion on the robot. And changing some other parameters, such as the rendezvous angle, you get a hopping gate. Any questions here before I jump to our corporate overview? Alrighty.
Any questions, guys? Very cool work, very close to what I do here in motion planning also. And I'm glad to see that you used to use Mathematica back there. So
Yeah.
okay, very cool.
Are you guys using it?
Yeah, maybe a quick question, Joe. So I see in your phase plots, it was theta versus theta dot, or maybe I missed something over there.
Sorry, can you say that again?
In your phase plots, if you go back one slide.
Yes. One more.
Theta dot. Yeah.
Yes.
Theta 2 and theta. Okay. So you do look at the phase plot. Any information
Yes.
you're pulling from that phase plot other than the shape?
Well, to explain, theta 1, 2 and theta dot 1, 2, that's the angle of the baton with respect to ground.
Okay. Okay.
Okay. And it really shows you if you're, well, for example, on these larger phase plots here, it shows you that you're on a limit cycle with a certain level of theta dot. And it tells you if you're tapping or if you're dragging in the case of the smaller ones.
Okay.
And you look at bifurcations, you look at coexisting limit cycles, etc.
Okay, thanks.
But really, these phase plots don't give you necessarily a velocity profile of the gate. And this plot here shows it. You know, you've got the average velocity of the baton with respect to the angle, the rendezvous angle beta. And you see how it moves forward in certain scenarios. It goes negative in the negative direction, and it can be going negative direction and also tapping forward. So dragging backward and tapping forward.
Okay, thanks.
Absolutely. All right, let's talk about Bastian Solutions. We are a system integrator. We work in the warehouse automation industry for the material handling businesses. We've got over 900 employees. I think we're closer to 1,000, and half of which are engineers. We work with a large amount of suppliers. We partner up with them, and we've got a big customer basis in the US and internationally with Fortune 10, Fortune 100, Fortune 500 companies. And we are number 15 in worldwide in material handling system suppliers, and number 3 in the US. Got offices obviously around the country here in the US, and a national presence. And I'm part of the mobile robotics office in Dallas, Texas, where we develop mobile platforms, mobile robotics, R&D projects, all of that. About 3 years ago, a little less than that, we got acquired by Toyota, the Toyota industrial side of the business, not the motor side. Motor side is like a relative in the family. We have basically solutions for every challenge in the warehouse automation industry and the material handling industry. And we've got presence everywhere. Our goal is to become number 1 in the world. And luckily, we're moving in the right direction still. We offer different services and support. We do consulting for companies in the logistics, supply chain. We help them design their warehouse according to their needs. And we also we can design it, we can implement it, we can integrate control systems, conveyors. We can work with the customers also to implement warehouse management system and warehouse control systems to control the material in the warehouse and all the equipment there. We do project implementation from A to Z. So we can buy equipment, we can design and manufacture equipment, install it at customer sites, and commission it and get it going. And then we do training for the operators, customer support 24/7. and of course, maintenance and parts. Now, here is a brief overview of the applied technologies that we can integrate. We are a system integrator, so we find the best solution for the customer, the best of breed for every unique solution, basically. So we don't always, let's say if we're installing a piece of conveyor, we have our own conveyors. We also partner up with suppliers or different conveyors, depending on what the customer application is and what their needs, we would recommend the right fit for them. And just to briefly, I will be going into more details on the technologies that I have highlighted here, but we do everything from picking technologies, ASRS, which is the automated storage retrieval systems, goods to person technologies, retail and e-commerce, AGVs, those are ground vehicles, navigate in warehouses. We do a lot of robotics, different applications, which I'll briefly highlight later on. Goods to robot, I'll get to that later. I don't want to touch it right now, but I want to bring up that we do a lot of custom automation. So really one-off projects, one-off automation systems, material handling systems. We've got a group that is focused on that, very, very smart group of engineers. And obviously we do conveyors, sortation systems, racks and shelving as well, but I'm not talking about them today. All right, this is an overview of the industries we serve. We've got different customers in different advanced industries, from aerospace, automotive, consumer goods, e-commerce, food and beverage, pharmaceutical, industrial distribution, manufacturing, retail, apparel, and third-party logistics. These are the UPS, the FedEx, etc. I'm going to show briefly a couple of these renderings of projects we've implemented at different customer sites. I think this is Amway in Japan. This is Johnson & Johnson, which is very well in the news recently with since they're working on COVID-19 vaccines. And this is Asian Paint. This is one of the largest paint companies in India. And that gives you a scale of what we do. All right, let's dive into warehouse automation technologies. But before I do that, let's see why we would use automation. Well, first, obviously, you want to bring the cost down. There are different ways you can optimize for cost with automation. But really, the major challenges are the labor. Labor force is declining. The wages are increasing. Now, of course, this slide is pre-COVID-19, and I'll touch on that in just a minute. But before COVID-19, unemployment rates were so low in the US and Europe and other countries, and it's hard to find people. The workforce pool is just declining. You can't find people doing these jobs. And in general, the jobs that you're trying to fill for warehouses are high turnover jobs. People don't last in them for long, a few months, maybe a year at most, and then they quit. So it's a very challenging HR problem for companies to keep people there, especially if you have seasonal demands. I don't know if you're here about around Christmas time or other holidays, some companies need to hire a lot more people to keep up with demands, but then they have to let them go. So that's a challenge, and automation is a solution to that. And obviously, the wages are increasing, and they continue to rise. And a lot of times when you employ technologies and automation, people look for 1 to 2 years of payback, so high ROI, so that they can recapture their money and save on cost. Another important reason why I use automation is the safety and ergonomics. Obviously, you can see in the video here, got people running around, picking up items. They may trip, they may stress their shoulders, their back. It's an unpleasant also work environment. You got to be doing something very tedious, but you cannot make mistakes. You could be working in a very hot environment or in a freezer environment, which I've been to, and it's really not something you want to be in. You also have danger around warehouses. Forklifts are, for example, #1 cause of death in a warehouse. So a lot of people are looking to automate forklifts in warehouses, so they prevent that. Now, you use robots, you improve productivity. Obviously, you can scale, you can increase number of robots, you can increase certain areas, have repurpose it. It's very modular in general for shifting markets. So you can, if you have AGVs, you can have some you can later add to the system. Invested a couple of years down the road, your production is increasing, so you can add more robots, for example. You can have an increase in throughput rates, obviously improved efficiency, you don't have mistakes in orders. Also accountability, which in Lebanon, when I go and visit, I keep hearing about somebody went bankrupt because such and such stole from them, from the warehouse, this and that. If you have automation, you have the right systems, you can keep track of everything. And of course, you can leverage space much better. You can get a greater cube density if you go vertical, which will be something I'll touch on later. One of the disruptive technologies that affected our world is the Amazon effect with same day, next day shipping. All that, put a lot of stress on other companies to survive. They needed to add automation. So finally, let me move on and talk a little bit about social distancing. As you all know, we all had to go work from home, but we still want to eat, we still want medication, we still want everything to be delivered to us. And how do you do that? Well, some of these companies are having to rely more and more on automation. And I was looking at an article before this presentation by Georgia State University that predicts that companies will accelerate the implementation of automation to meet the challenges of the pandemic. And we know that firsthand from our customers as well. All right, let's move on. Picking technologies. This is where we start talking about the technologies and the overview in the warehouse automation, but this is a standard way to fill orders. These are voice picking or pick-to-light systems. You got associates picking items from different shelves, filling orders, running around the warehouse. This is not automation, but it gives us a good idea of how things operate. Some of the conventional automation systems are conveyors and sortation systems. And you see them here. These are some of the products we offer. Van der Lande, which is our counterpart in Europe, same family within Toyota. This is one of their recent offerings. It's a pouch system that you can store items in it, and it goes in vertical space and stores it. Next up, I'll talk about a bit of ASRS. These are automated storage and retrieval systems. I don't know, I'm sure you've seen something similar to that, like storing cars in a vertical parking. These are very similar. I remember the first time I saw these in a warehouse, I spent probably 3-4 hours just watching it run. That's amazing. You've got a crane that goes up about 40 meters in the air, picking up pallets that are a couple of tons in weight. And really, these are great to store pallets in a warehouse or a distribution center, and especially also if they're refrigerated or freezer applications. Another type of storage system are these goods-to-person shuttle systems. It's a modern method for order fulfillment, and where the product is moved directly to the operator, who can pick what is needed to fill the order, and allowing for an increase in efficiency and accuracy of the picking process. It is ideal for agronomic picking, easily scalable, and offers a dense storage footprint. The one on the right is the auto store. I'm going to show you a rendering at Puma in a bit of how this system is operating, but it's pretty neat. You get the high velocity items or high frequency items stored on the top layers of that grid, and the low velocity ones in the bottom. And if it's a retail customer, you think like in the season where it's summertime, they've got certain t-shirts on the top side. Later on in wintertime, you get the jackets and the heavier clothing on the top side. So that's a Puma rendering, one of our customers, where we've integrated this auto store technology. Next, we move up to AGVs. These are automated guided vehicles. There are many different types in warehouses currently. Some of them are tuggers, so they pull carts. Some of them, they pick up pallets and move around. And there are different types too, where they pick up shelves, like the Amazon Kiva. It picks up a shelf and takes it to an operator where they pick the items from the shelves and fill the order. And the last one on the right, bottom right, is a mobile platform that follows the operator so that they don't have to carry these bins around the warehouse. Sorry, Nabil, I don't know why you want to annotate. Please let me know if you have any questions.
No, thank you. That was a mistake.
No problem. I figured. All right, there's a wide use of robotics in the warehouse industry. It really is getting more and more advanced with the development of new types of end-of-arm tools that are very intricate to pick different items, different shapes. Also due to the sensing technologies and lasers and camera vision and all that, this is enabling this type of applications and this type of system in the warehouse. You see a lot of robotic palletizing and depalletizing systems that pick and I show a video of that on the bottom right, where a robot is picking different size boxes. This is mixed case palletizing. It's a very challenging setup. And on the top side, you see item picking, where each is picking place. So use the robotic systems for machine tending, where you pick items from CNCs, for example, or some other manufacturing equipment, to packing, document insertion. All right, so these were the best commodities and general technologies used in the warehouse automation industry. I'm going to talk now about the new trends and the emerging technologies. Those are the new technologies that are being developed or used. First one is goods to robot technologies. So we looked at each is picking and pick to light systems, where the person is going to the goods to pick the items. We also looked at a goods to person robot with the shuttle system, where it brings the tray to the operator to pick the items. But what if you were to have a robot there? And this is where you bring the goods to the robot and get it picking, which will obviously save in labor costs. But these systems are still mostly in beta phases. They're not widely available because of the variety of these items that they need to pick. It's massive, thousands and thousands of stock keeping units that automation is not there yet. So it's all work in progress. Another type of technology is the robot to goods technology. And this is where myself and my team are involved in it. This is where you start getting the robot to go to shelves or to the product to fill the orders. And that's another way to improve productivity. It is less restrictive also than conveyor-based system because you can definitely scale it, and you don't have to have conveyors that are always there. You can remove the conveyors and have these mobile platforms go everywhere in the warehouse. You can also put them in brownfield facilities or existing manual picking aisles, and I'll show you some videos later on. So really what we've done at Bastian when I first joined is create a concept for each's picking or batch picking. It's a mobile robot that drives in aisles and it picks items from shelves and fills the orders on board the robot. We did simulations to figure out how many orders we can put in a robot or we should put in a robot. And that depends, of course, on the customer, products, on their customers' orders and the order profile and the throughput rates. And you can optimize for that. Here you see the robot. It's got about 16 bins on board. And that means it's filling 16 orders at a time. Let me talk a little bit more about the technology we use on this mobile platform. So first, you've got an industrial arm. It's an industrial 6-axis robot that's got a reconfigurable or custom environment tool to pick different items for different customers. It sits on a gantry. This is a gantry. It's like a bridge that allows it to traverse along the length of the platform to reach into the totes or the bins in the front. It uses a mobile platform. It uses omnidirectional wheel-based. These are Mecanum wheels. I don't know if you guys are familiar with those, but you'll see the videos later on. And we use scanners and LiDAR for navigation purposes. We also use opportunity charging. This is a way that we can allow the robot to operate 24/7. We employed wireless charging technique. These are inductive charging, similar to how you can charge your phone on a pad. But instead of charging batteries, we charge ultracapacitors. So you can quickly charge those capacitors and rely on the high power density of those capacitors to provide power to your system. So when the robot is driving in an aisle, it can be charging. If it goes out from one aisle to the other, it can rely on the capacitors to navigate. One feature that I'd like to talk about, and I hope you guys are familiar with it, it's ROS Industrial Robot Operating System. This is an open source platform for robotics. Are you guys using ROS? Anyone doing research or work with ROS?
Yes, Rima, Tahir, maybe you want to answer this question?
Hi.
Rima, graduate students.
Yes, I do use ROS a lot. I work with SLAM to be specific, simultaneous localization and mapping.
Awesome.
Yeah.
Well,
We teach it in all our labs, so we're very familiar.
That's awesome. Good to hear that. All right, so I don't need to talk about it. Good. All right, so what we do is we also create simulations to figure out how many robots we need, how fast we need to drive the robots. This is how we design systems. We go back and forth between different iterations of the prototype and the simulation. And here you see robots working together to fill orders. They're picking items from shelves and dropping them off at drop-off stations. When the bins are empty, we put the empty bins on a trash conveyor or a return conveyor. We put it far back in the simulation, but it's actually right on top of the robot. We launched the concept at trade shows.
So maybe a quick question here.
Yes.
If you don't mind. So in the simulation, is this a full physics simulation or just a logistical simulation?
This one is a logistics simulation. This is not an emulation. We do emulation for, let's say, navigation systems. Yes, when we navigate in with the model of the robot, or if we create other things, we use Gazebo, for example, as a physics engine. Okay. But this is this is more of a logistics simulation. It's called FlexSim, and it allows you to. It's a very robust tool for different applications, but it's pretty neat for our supply chain and warehouse simulation.
Okay, thanks.
Absolutely. So here we launched the robot. This is at ProMat 2017. We put a small setup. It's a demo setup, of course. We do have a setup. We made it easier for us to do a show, but obviously we've put these at customer sites, and they look a lot faster in real life and a lot meaner. So here you see the robot can crab sideways. We put omnidirectional wheels so we can navigate tight aisles. And you can see also here replenishment. We put another generation at another trade show. This is Logitech in Tokyo. That was the second generation of the robot. And we put a special interval tool that we've developed also. It's a 3D printed interval tool that's got 3 fingers. You can grasp with it, and you can also use vacuum cups on the tips to pick items. So depending on the item shape, you can pick it differently. All right, another type of robot to goods application is the Ultra robot that my team and I have been working on. This is a robot that is specific to applications where it's a very challenging environment for operators to work with, and that is the loading and unloading of trucks at the docks. Operators can be picking up items up to 50 pounds or 20 kilos and lifting them up high. It's very stressful for the shoulders, the back. It also is a very hot or very cold environment, so it's very unpleasant. A lot of people try to automate this process by putting a robotic arm in there. But the problem with these robots, they're not designed to be in a confined space. So what they have to compromise with is speed. They have to slow down the robot to maneuver around singularity and obstacles. So what we did is we designed a platform. It's a mobile platform also, but it's really designed from the grounds up for this application. And the concept is it's a mobile platform. Oops, the video. That's a robotic conveyor, and it drives into the truck. In the case here, it's unloading. It's got a telescoping conveyor attached to it that follows it into the truck. And it goes to where the product is and it picks it. And it can also do loading as well. So we did a simulation with FlexSim also to look at what type of speeds we need to design accordingly and meet the throughput rates that would be required to justify the cost of this technology. And we built prototypes. This is our beta prototype that we have put in the field. We've got several of these robots in customer sites. It really is, again, a robotic conveyor. It's got an interval tool with 6 degrees of freedom. It does have an omnidirectional wheelbase as well. We've got a retractable mast on board, so we can extend and retract, and we can park the robot if you've got confined space in the warehouse area. And we also use cubing techniques to scan products in or out, as well as we use LiDAR and navigation to drive in and out of the trucks. I show a video here of one of our robots in the field. This is loading containers, shipping containers. You see this is from the back side, it's got the telescoping conveyor, and this is a loading application. What you see is the robot is loading in a serpentine fashion in rows, boxes. And we can load boxes in basically columns as well. And what it does, you place boxes, you justify the box so you can clear up space at the end so you can squeeze another box in. And here you see it driving back on a dock leveler. More views. And it's designed to handle boxes up to 50 pounds. Now, obviously, it does not do well with if you have boxes of different sizes or if they vary in quite the amount, but we are working on it. It's on our roadmap to solve. Right now, we focus on applications where the product is semi-uniform to some extent. Oh, you can also do the reverse. This is a setup we did at a show where the robot is unloading boxes, well, it does loading and unloading. And here in this video, it's unloading the boxes. And we've developed our own vision to do this work. So we do employ convolutional neural networks and AI to detect the boxes, along with conventional computer vision techniques. So what we've created is a cost-effective solution for loading and unloading of trucks. Customers get their money back in a couple of years. It's a very reliable system. You can easily recover from faults. So if you have a bad case or the robot is stuck somewhere, you can easily recover from that scenario. You can reduce turnover by moving associates to more important areas of the operation. You still need to have a supervisor for these robots. So if you've got multiple number of these robots in a warehouse, you still have to have someone trained. So what you do is you take the associate that was loading the truck, you train them on the robot, and you have them supervise with minimal intervention. They do have to, however, prep the trucks, make sure the robot is in the right location, and run them. These robots can run 24/7, and you can have one robot serving 2-3 dock doors at the same time. I like to brag about what the features are for this robot because it was not easy to get there. Loading or unloading 1,200 cases per hour is not easy, and doing it at 99.8% reliability, so you don't get many faults. Even if you get a fault, you can fix it in less than 3 minutes, so with a mean time to repair. I like to brag about that. It's pretty impressive. I don't think anybody else in the world has been able to solve this. So quite, the attention we get every time we show this to customers or at trade shows, people love them. And one thing I would like to note here is we conform to all the safety standards in our industry. I'm gonna move a little faster here. I've got about maybe 10 slides that I'd like to cover. So hang in there. Obviously, I'm moving to another technology that is emerging and trending right now, and that's vision. A lot of companies, a lot of researchers are working in this field for machine learning vision, and we use it quite heavily for different applications. I've got a team working on vision for unloading boxes in trucks. You can imagine the type of challenges we see with boxes of different sizes, different shapes, different decals. They've got markings on them, they've got labels on them, and some of them are even destroyed through the trip that they've gone. So quite the challenging, but very interesting field that is emerging right now. I'm sure you've seen augmented realities. This is a HoloLens that we've got a software team that developed a way to do manual picking with that HoloLens, and it points to where the shelves need to be picking from and how many items. And you can do an acknowledgement, whether via voice or with a finger gesture. It's pretty. I've tried it. It's pretty cool, and it's natural. You get used to it very quickly. It helps with accuracy and productivity, and you can get fast adoption as well. Obviously, a lot of AI that's emerging right now in supply chain, whether it's for chatbots, for operational procurement, whether it's supply chain planning. You can forecast inventory through an AI system. You can optimize the delivery of the goods. You can also plan logistics and shipping, so you get faster and more accurate shipping there. and reduce the lead time and transportation expenses. So always working towards efficiency, cut down the cost, obviously. And you can do also predictive analytics for supplier selection, supplier relationship management, and also predictive analytics for maintenance. Internet of Things, or IoT, this is something that we were involved with to do asset tracking. So if you have got a pallet that's in a warehouse, you can track it real time where it is. You can also track it if it's being transported across the nation. You can keep track of, for example, temperature variation, especially if it's, let's say, a food item, or if it's a fragile item, you can have inertia sensors and force sensors detect if it got, I don't know, hit one way or the other along the way. It can also deter theft and aid in recovery. But overall, it's, again, helping with improving the efficiencies across warehouses. And last one is 5G networks. The only thing I'll bring up here is the quality of service that you get out of 5G. It enables mobility in a warehouse for AGVs and AMRs. You can have better transition and handoff between access points, so you don't get drop connections. And you can also have a better feed from cameras that way. But there are also other benefits to 5G networks, but I'll keep it to that for today. All right, let's talk a little bit about the challenges that we've been facing, or we face when we go into an existing facility that already has some sort of automation, but it does have different kinds of infrastructure that already exists there. So you can imagine the first one would be localization and navigation, but these are forever changing spaces. You get people walking around, you've got other robots walking around, but then you also have pallets that are being dropped randomly in the aisle where the robot needs to drive and navigate. Some type of navigation systems rely on natural features or fiducials, so those may be covered, and that poses another challenge for the mobile platforms to localize and navigate. So you see a lot of companies and startups working in this field. Some of them use even AI and vision to navigate. Some of them look up on the ceiling and memorize the ceiling. Others look down on the floor and the ground and memorize the floor to navigate. But really, of course, with the advancement in motion sensors, you can prevent collisions. So we employ safety scanners, safety rated components to prevent collisions, whether with static or dynamic obstacles. So that's another layer of safety that mobile platforms they have to use in warehouse automation. Another challenge, well, a lot of the products are not designed for automation. They're designed for us, for people, whether it's designed for us to easily pick it up and place it somewhere, or it's designed for our eye, so it's appealing to the eye. That's with the decals and the shape of it, but they're never made for robots. And that poses always a challenge for us, especially like a pallet like this. If you were to create it with a robot, that's a nightmare for any roboticist. But at the end of the day, these are challenges that we have to solve and we have to work with. But then you also have not only the product, but the setup as well and the work environment. For example, with the Ultra Robot, you get trucks of different sizes, different shapes, different types. Some of them have walls destroyed, and you got to deal with it. You don't have a choice. So those are some of the major challenges that we see. And you got to try to think for all of these different scenarios that you're in. By the end of the day, you've got to go and put a robot in the field and test it and learn from it. Another challenge we see is people. Well, safety. One, you've got robots working next to people. You got collaborative environments. You also have people not following the standard operating procedures. We've been close before, for example, with the Ultra robot, where the truck driver just decided to leave and take the truck with him while the robot is inside. Well, luckily, we've got ways to, we thought about it beforehand, and we had ways to prevent that from happening. But these are the problems that you see mostly with people not being familiar with the technology, or they're not following necessarily the standard operating procedures. Obviously, you have to follow safety standards. Sometimes you create new type of robots and technology that they don't have safety standards, or the standards are so old, they're outdated. And what do you do there? Well, you jump in and help create these standards. Also have people that are afraid of these robots. They think they're going to take off, they're taking over their jobs. Well, and we see that. We see people sabotaging the robots. We see people covering up the cameras, moving the cameras. And what we end up doing always is train and get those people to re-specialize and retrain, so they're working in a safer environment, friendlier environment, and they can work for a very long time in that setup. And I think one of the most challenging one is the customer, obviously. You go in a facility that's already operational, they're running production, and production is mission critical. You get a prototype, you put it there, or a new type of robot, and you create downtime, and you create a bottleneck for that warehouse, they will hate you. And you know, one of the setups we've done, if you have a 1 hour downtime on a line, that is equivalent to hundreds of thousands of dollars, if not even millions, in operation. So you got to think about that. You got to think about how the customer is thinking, and work with them as much as possible. All right, well, finally, to give you a piece of advice, I always tell my team, do it right from the first time. Don't cut corners. This is a good saying here, where if you don't have time to do it right, when will you have time to do it over? By John Wooden. And really, if you cut corners, you're going to have to come back to it and fix it, whether it's a homework, whether it's a project, senior project, whether it's a robot for a customer, or whether if you're building a country. I'm not sending any political messages here, but whatever you do in life, try to do it right from the first time. Put your energy and efforts to it, and it'll come to fruition. I listened to a seminar over 10 years ago. It was a very boring seminar, and I don't remember anything out of that seminar except for, at the end, the presenter said, hire A players. A players hire A players, B players hire C players, so they make them look good. So you guys better be A players. I know you are. And when you go in the industry, whatever you're doing, make sure you create a good culture, you treat your employees the way you want to be treated, but at the same time, look for the A players, because they will propel the company, or they'll propel the work to another level. With that, I'd like to thank everyone for listening. I hope you enjoyed the conversation and the talk here, and please let me know if you have any questions.
Thank you, Joe. This was fantastic and very informative. It's always when you see an idea and you say, oh, why didn't I think about that? That tells you it's a great idea. So this is especially true for the Ultra robot. It's so simple and very impressive statistics on the performance of the robot. So with this, I would like to thank you again, and I would like to open the floor for questions from the audience. Please go ahead, unmute yourself and ask your questions.
Thank you, Joe, for the wonderful presentation. This is Danny Abu Jawdi from Mechanical Engineering. I am an assistant professor. And I think you really gave us a good talk with the applications, and it's especially easy for us to relate to what you're doing, because we have students who are working on autonomous vehicles in different contexts. So I have a few questions for you. First, I mean, if you want to define the skill set or the academic umbrellas which you need in your design of general autonomous vehicles. So you've mentioned them, I think, throughout the presentation, but if you can summarize them for us, please, and something which is specific to your application in warehouse application. And then I have other questions which I'll ask after this.
Great question, Danny. Robotics, I always say it's the fusion between mechanical, electrical, and software engineering. So obviously the team I have, and the team I've been working with is a multidisciplinary team. We've got mechanical design engineers that have a passion in robotics. We also have electrical controls engineers that have the right background, because you've got to have a electrical industrial background, as well as the software group. This is a team of engineers and data scientists from different disciplines. A lot of them are actually mechanical engineers that went into the software world. But you know, the team is a multidisciplinary one, and we also have production people that work with us in prototyping.
Yeah, thank you.
Obviously, you know, from a high level, you've got to have different project managers, sales engineers to work with customers. You got to have technicians on site. But the team that I have is, you know, it's a small team. People wear multiple hats, and they support in different ways.
Thank you, Joe. And I've seen in one of your slides, you have mentioned the singular control. So can you please comment on this? And also, have you looked at robots at the same time if you want to do the optimization for in the multiple agent settings? So are you looking at distributed control, distributed path planning, or something of this sort?
Yes, so the singular controller, it's an industrial PLC that can basically control up to 64 axes at a time. This is used in industrial setups where you've got robots working with conveyors, with other electromechanical systems, and you put them all under one brain. So you've got a seamless integration, synchronization of all these systems. And the reason we did that with the mobile robot and with the Ultra is because you're controlling a robotic arm, but then you're also controlling wheels and a gantry and other actuation systems, and you've got to have them all synchronized at the same time so you don't waste time. You've got a very efficient system, and hence why we've done that. For fleet management, we do have another team working on that. They work on different ways to optimize, but it's not very advanced as you're thinking.
Thank you a lot. That was very fruitful and helpful. Thank you.
You're welcome.
Hi, can I ask something?
Yes.
So my name is Rima Dahir. I spoke before. I just want to ask, so usually in such fields, what kind of expertise do they ask for in terms of academic levels? Do they look for people that have graduated with a master's degree or with a PhD? Or what's the level of expertise that is needed?
Well, I would say all different levels, Rima, because the way I started my team, we hired people that had zero experience, and we still hire people with zero experience. They just have the passion, the right attitude, and a good background. But then also, if you have specialized areas, you start looking for people with a master's degree or even a PhD degree. So it varies depending on what the role is, what the background, and the needs for the business.
Okay, thank you.
You're welcome.
Hi, Joe. I have a question. This is Nasim Dahir. I'm part of the Vision and Robotics Lab, so I collaborate with Eli on different projects. And in fact, some of the projects that you highlighted in today's presentation, which was wonderful to see, are similar problems that we worked on, especially in the past couple of years with BMW Logistics Robotics Group. My question to you is, do you do all of this work in-house, or do you collaborate also with academia or other, let's say, consultants or contractors?
Naseem, very, very good question. When we first started, we didn't have the resources. I started looking into partnering up with different companies, consulting groups, or researchers. But then we realized that if you rely on other companies or a third party, you don't hold the knowledge internally, and that puts you in a very tough spot in the future. So the decision we made was to hire and train and do everything from scratch.
Oh, okay. So even now, if you have open problems, you don't you don't collaborate with universities. You try to solve it on your own.
It depends, but in the case of the vision I'm talking about, but we do a lot of research with different companies. We have partnerships with universities across the US. We have partnership with different suppliers. But in our case, with the vision system, we have options. We integrate, other people's technologies too. But for our needs, we wanted to create a product that we can maintain. So if, let's say, company X created a product, we used it, that company goes bankrupt, we're in a tough position with the customer, because these robots, they have to operate minimum of 10 years.
Right.
So that we've decided to create things from scratch and not have black boxes. It also puts us in a better spot with the cost and the revenues.
Okay. Maybe Eli can follow up with you on this and we can show you some of the stuff we worked on and see if there are any opportunities there. I'll let Eli.
Absolutely. I would love to check out what you guys do.
Okay. Thank you.
Hello, Joe.
Hello.
My name is Antoni Shadid. I'm studying mechanical engineering. I'm in my 4th year. I wanted to build kind of on what Rima had mentioned. As someone who isn't really sure what they want to do upon graduation, I think that's the case for a lot of people. How would you recommend that we build our skills in robotics? Would you recommend trying to go for a job right away, or should we go for a master's degree right off the bat? What's the proper path for that?
Well, Antonio, it's a good question. It depends on, it will really depend on where you want to be down the road. The easy path is you knock out a master's degree out of the way and do it right after graduation. Sometimes it's a little hard to get out of work and go back to doing a master's degree. I've seen people do that, and I have huge respect for them. I've seen people get out and do a PhD program. I even have more respect for them. In my case, I did it all at once. For our industry, I think it's better if you got little more than your average, people, where you've got a master's degree, you stand out a little better. And at the same time, you take your knowledge to another level. But either way, there's no good path. I mean, obviously, it's a personal preference. And I obviously do recommend to get an advanced degree. I don't know if I answered your question right, but it's a tricky one.
Yeah, it's not a straightforward question, so I didn't expect a straightforward answer. But yeah, thank you. That's helpful.
Right.
Other questions, guys?
Yes. Hello, Joe. Thank you for the presentation. I noticed it was very mechanical and programming oriented. I'm a senior in civil engineering, and we're looking for our final year project to talk about automated warehouses. Are there like any differences structurally or anything like you could help us with from that sector?
Yeah, one thing that comes to mind is seismic areas like in California or Japan. A lot of these warehouses, they have to design accordingly. And what they end up doing is put sensors for seismic activities and earthquakes, and they will shut things down or they will trigger safety emergency stops. It'd be interesting to see if you guys can think of some sort of stability analysis, for example, on these ASRS cranes or other structures. But I'm thinking on the inside of the warehouse, not the outside, not the walls, for example.
Thank you very much. That's actually very helpful. Thank you.
You're welcome.
Maybe Joe here, a follow-up question, because we need to help our civil engineers here. In terms of, I know if like now buildings require utilities, so water, gas, and maybe sewage. Could they, I mean, if you plan to have this space to be used as a warehouse, maybe embedding something in the floor like magnets or other kind of sensors to help in the navigation, would that be maybe a possibility for them?
I'd have to think about it because, as you know, there are rebars in the concrete. These are metal, shredded metals or metal bars to reinforce the concrete of the ground. And one thing that came to mind when we mentioned that was when we did inductive power transfer to the mobile robot, we had to embed a certain type of wire. It's called Litz wire in the concrete. And that's how you wirelessly transfer power to the robot through that wire. And the problem, one of the challenges with that was it gets affected by ferrous material. So if you got shredded rebar or shredded metal or rebars in there, it affects the magnetic field and it heats up the concrete and reduces the efficiency of the power transfer. What we had to do is cut out a slab, put fresh concrete, move the ferrous material certain amount of distance away from these from the Litz wire, and that was an expensive process. And you can use that also for navigation, but a lot of the navigation systems that were used for AGVs are magnetic strips. Also, they lay them down on the concrete, and they work just fine. The problem is they strip off or they go obsolete if you need a new path lane. I don't know how to answer the question, but I'm just throwing some ideas out. Navigation-wise, a lot of people are moving away from fixed, let's say, magnets or electromagnets or fiducials in the concrete, just because things keep moving around.
Thanks. Other questions? Okay, I think we're done. So, Joe, I'd like to thank you again for the precious time that you have allocated for us. This was very fruitful for us and very informative. Thank you again, and hopefully we'll stay in touch. You have a great day, and thank you.
Absolutely. Thank you for the opportunity, and hopefully we'll stay in touch.
Okay, take care. Thank you all for attending.
Thank you. Bye.
Bye-bye.